All right, so we're going to be looking at geometric sequences today. And a geometric sequence is a sequence with a constant multiplicative ratio. Between terms. So what does that mean? Well, when we did arithmetic sequences, we saw that there's a constant plus or minus from one term to the next. With a geometric sequence, there's a constant multiplication happening from one term to the next. So if we look at our first example here, we can see that our first term is 2, the next term is 6, so it's like a times 3. And then 6 to 18 is another times 3, and 18 to 54 is another times 3, and we keep going. So times 3, times 3, dot, dot, dot. And it keeps multiplying. So repetitive, constant multiplication. Okay. And here's another one. So this one's decreasing. So it's 100, like divide by 2, divide by 2, divide by 2. But we said it's a multiplicative ratio, which means we have to represent that as a multiplication. So we have to think, what can we multiply by to have something to divide it by 2? And we are multiplying by a half. So this is times a half. Times a half. It's halving each time. So these multiplicative ratios are similar in concept to some of the stuff we saw in exponentials, a repeated multiplication happening. Okay, and we'll see with our general equation here for geometric sequences that it's very similar to our exponential equations formula because this is an exponential repeated multiplication relation. So the term is equal to a times, I'm going to use a dot to denote multiplication here, r to the power of n minus 1 in the exponent. Okay, so notice that the n minus 1 is in the exponent. We're going to have to do for BEDMAS, we have to deal with that exponent subtraction first. Okay, so similarly to our arithmetic sequence equation, Tn is the value of term number n. A is the value of the first term. N is just the term number. With arithmetic sequences, we have D for the constant difference. Here we have R. R is the multiplicative ratio. Let's spell that correctly. Multiplicative ratio. So it's a thing that we're multiplying by to go from one term to the next. Okay, so let's look at our first example down here. So here we want to find term 11 of this sequence. So it goes 2, 6, 18, 54. So that's the same one we saw above. So let's see, we know that the a value is 2, and we know the ratio from one term to the next is repetitive multiplication by 3. Okay. And here it's asking us for T11, so that'd be where n is 11. So T11 is going to be A2 times R3 to the power of n minus 1. Okay, so very careful here if you do BEDMAS. If you try to punch this in your calculator all at once, that's absolutely possible, but it is very easy to make a mistake by not correctly using brackets and things like that on your calculator. So I'm going to go through it step by step here. So we have an exponent inside the brackets up here. That's the first thing we need to do. 2 to the power of 3, sorry, 2 times 3 to the power of 10. Okay. BADMAS tells us brackets, we're done that. Exponents, we have to do this 3 to the power of 10. Do not multiply this and make it 6 to the power of 10. Deal with 3 to the power of 10 first. Okay, so you could use, you're definitely going to want to use a calculator for that one. 3 to the power of 10 is 59,049. It's a big number. And then we do the multiplication by 2. And that gives us a t. The 11th term is 118,098. Okay. Let's take a look at the next one here. So this is the same example sequence we saw before. So we start at 100, so our A value is 100. Our R, our ratio, is a half, because it is halving, multiplying by 0.5 or dividing by 2. We can't write a division in, we write it as a reciprocal multiplication. And the term we're trying to find here is the 8th term. Okay, so T8 is going to be 100 times 1/2 to the power of 8 minus 1, which is 1/2 to the power of 7. Okay, so we can punch that straight in our calculator, but you got to be a little careful. And I would make sure you try this on your own as well and see if you get the same thing. I'm not going to walk through all the steps this time. We get 0.78125. And if you do punch this in your calculator in multiple steps, say you do 1/2 to the power of 7 first, I would keep all those decimals in your calculator, don't round, and then multiply by 100. So we get this nice decimal. It doesn't require scientific notation, but your calculator may give you the 1/2 to the power of 7 in scientific notation. Okay. So similar with arithmetic sequences, sometimes we don't know the beginning of our sequence. We just know 2 values from different parts of our sequence. Okay. So it's a little trickier to rearrange these when we have 2 equations we write. So we're going to do the same thing. We always want to write the later term first. You don't need to, but it does make it a lot easier. So term 7 is the later term we know, is equal to 96 equals A. We don't know what A is right now. Times R. We don't know what the multiplicative ratio is yet. To the power of 7 minus 1. So to the power of 6. And from the term 4, we know that's equal to 12, which is A, we don't know what A is, times R, don't know what R is, to the power of 4 minus 1, which is 3. Okay, so we want to do something like substitution elimination. Now, adding and subtracting these equations isn't effective because A and R are multiplying each other. So we can't actually subtract these terms. But we can, just like we can add and subtract equations in elimination, we can also divide equations in elimination. So we're going to divide these two term by term. So 96 divide by 12. We need a calculator for that. But that's 8. A divided by A, well, that's just 1. A to the power of 0, or 1. R to the power of 6 divided by R to the power of 3. Oh, that's one of our exponent rules. So I'll write out the steps this time, but we don't always need to do that. R to the power of 6 minus 3. It's our exponent rules. So that's going to be 8 is equal to, do this simplification here, R cubed. Okay, so we still don't know what R is, but we're getting closer. Now, if we want to rearrange this, if this was R squared, we just square root both sides. Since this is R cubed, We can cube root both sides. And your calculator may have a cube root button on it, and you could use that for this question. But in general, we might get things like r to the power of 7. Well, I don't have a 7th root button on my calculator, and I don't think you do either. Some people do. So we might want a different strategy. So what we can also do is we can use those fractional exponents we know about, right? So I know that a cube root is the same thing as an exponent of 1 over 3. So that's how I'm going to rearrange this here. So I'm going to put both sides to the power of 1 over 3 cubed to the power of 1 over 3. And these exponents cancel out. And I can punch that into my calculator. I do have to be careful. I recommend you try this on your own. 8 to the power of bracket 1 divided by 3, close bracket. Your calculator should be able to do a fractional exponent no problem. And we get 2. So r is 2. Okay. Now that we've done that, just like before, we can plug that in to find the a value. We can plug it into either of our equations up here. I'm going to plug it into the one with smaller numbers. So I'm going to say 12 is equal to a times r. R is 2 to the power of 3. So once again, we're plugging this in up here or there. All right. And we can rearrange this. So we get 12 over 2 to the power of 3 equals a. And 2 to the power of 3 is 8, so we get 12 over 8. And you use your calculator for this. We get a is 1.5. Okay. So now we know a and r. We also know the first term, which is one of the things it wanted us to find. So let's find term 11. So T11 is equal to a, 1.5, times r2 to the power of 11 minus 1, 10. And you can use your I would use your calculator for this one. Be careful plugging it in. Remember, make sure it's going to do bad math for you. 2 to the power of 10 first, times 1.5, and we get 1,536, or 1,536. All right. That is it for geometric sequences.